Hello and welcome to my presentation / lunch and learn today on SolidWorks Express tools. My name is Sashi Sitambaram. I am a technical solution specialist here with CAD Dimensions, and I am broadcasting live from White Plains, New York. I'd like to thank everyone for taking some time out of their day to join me. If you're at work or during lunch, I appreciate that. Alright, so for today's presentation, I'm going to give you a little bit of background on the 4 Express tools that we have in SolidWorks, which is Simulation Express, Flow Express, DriveWorks Express, and DFM Express. After giving you some background, I will show you an example and how to use these tools within SolidWorks. Now, what is nice about these 4 tools is that they are absolutely free. And what I mean by that is they are currently available in every version of SolidWorks, either the standard, the professional, or the premium. You'll be able to start using these tools as of today. Prior to SolidWorks 2015, these tools can be found under the Tools menu in SolidWorks. From SolidWorks 2015 onwards, they have packaged all 4 tools within an Express Products folder in Tools for easy access. So let's go ahead and start our presentation today with Simulation Express. Now, Simulation Express is basically a first pass FEA, finite element analysis software within SolidWorks itself. This is a structural analysis tool which will allow you to test and predict how a part will perform under a load. So once you have applied all the necessary conditions, it will show you the areas in which there are high stresses, and it will also show you how the part is reacting and deforming due to the loads and how the part is being fixed. Now this is very useful because it can essentially detect potential problems within your design. This is a type of tool you want to use on the early stages of your design cycle. So when you first start designing your 3D part, it's a good idea to run a Simulation Express on your part as you make changes to, say, the thickness of the part, an extrusion, a revolve, a radius. Run a quick Simulation Express to see how the stresses are being distributed. Make sure that you're not creating any stress pockets within your part itself. Now, another side note to keep in mind is that this tool is by no means a tool to replace any type of simulation testing that you may already be doing within your design cycle. Now, many of you know that simulation testing, FEA analysis, is very important when it comes to designing parts. And to address that, we do have a full suite of simulation products within SolidWorks itself, which you would use in the later stages of your design cycle for virtual prototype testing. Alright, so let's go ahead and jump into SolidWorks and take a look at an example here. So what I have here today is a hand wheel. And let's just say me as a designer or the engineer who's designing this 3D model now, I want to create the dimensions which would be close to what my final part would be. Now, a good way to predict dimensions such as the thickness of the part is to test it under extreme conditions. Now, as the engineer, I know that eventually a part like this, which is manufactured, may end up somewhere in a factory or a manufacturing plant, which may have high temperatures, may have different humidity levels, and this can essentially cause the parts to rust, especially if you have a hand wheel which doesn't get turned, for many months or many years. In some cases, it may start to end up rusting back here and get stuck. Now, when a hand wheel like this gets stuck, essentially what happens is You either crank it using your body weight, and if that doesn't work, you might start using some tools to crank the hand wheel. Now, in real life situations, one of two things can happen. The rust will break and you'll be able to start cranking that hand wheel again, or the hand wheel itself might break. So as a designer, this is a big concern for me, and I want to test this part out as I'm designing it. So to access SolidWorks Simulation Express, just go into Tools, Express Products, Simulation Express, click on it, and this will bring up the welcome page for SolidWorks Simulation Express. This page will give you some information, just the same type of information that I've given you before on what SolidWorks Simulation Express was built to do. And essentially you would just hit next here, and this is where you start to set up your simulation analysis. Now within this tool, there is 5 major steps to be able to run a full analysis. The first step is to create your fixtures. So this will imitate how the part is being held in real life. Now, just to kind of think back to our extreme case, what I said was that this part will be stuck. So essentially what I'll do here is I'll say add a fixture, and you can see that SolidWorks Simulation Express gives me some nice pictures here to show how the part will be held based on the selected faces. So if I select these 2 faces in here, this will simulate that part being held in place and not being able to move or rotate. Once I've selected those 2 faces, I just hit the green check mark and I'm done. At this point, I can add more fixtures, or I can hit next to move on to my second step, which is applying the type of loads. So hit next. Now for loads, you can add a force or a pressure. In this case, what I'm going to do is I'm going to apply a force which is in a crank motion. So something of this sort going in this direction or this direction. Now in real life, if I was going to crank this, I would probably pull down on this crank in this vertical direction. I probably wouldn't try to crank it in this rotational direction. It will be going straight down. So that's how I'm going to be applying my force onto this hole here, where a crank might sit. So I'll say add a force. Now to create the force is exactly the same as the fixture. You would select the face. However, when you select the face, the force will be applied directly onto that face. Now you need to take a second step to be able to direct that force in the correct direction. So in this case, I'm going to say selected direction, and I'm going to pick a plane which is normal to the direction that I want. So in this case, if I want the force to go down in this direction, I'm going to pick my right plane. You can see that that's my right plane right there. You can see how the force arrows now have changed to point normal to that right plane. So the force that I'm going to use here is I'm going to think about a hand grip is about 150 newtons. So 2 hand grips is about 300. I'm going to times that by 10, the magnitude of 10, so it's going to be about 3,000 newtons I'm applying onto this hand wheel. So that's quite a bit, but this is going to include all my safety factors within my part itself. So if it's built to last 1,000 newtons, I'm giving it 3 times the safety factor, where it will be able to withstand up to 3,000 newtons without any problems. It's always a good idea to design better parts so that it lasts longer, especially parts that come with warranties. So at this point, I can either add more forces or add a pressure, but I'm just going to hit next. Now the next step here is to add a material. Now it's important to add the material to your part, because that is where SolidWorks Simulation Express will extract the strength information of your part. So in this case, if I say choose material, I'm going to choose a realistic material that they're using for these types of hand wheel, which is probably a brass. So I'm going to say copper alloy, and I'm going to say brass. I'm going to apply and close, and you can see that right away it extracts the Young modulus and the yield strength, and this is essentially how the part will extract and deform, and this is going to drive the strength of the part itself, and it will show us some of the stress pockets, or maybe high stress areas in your part based on this yield strength. Okay, so I hit next. That's all you essentially have to do to set up the simulation. Now you just have to hit run, allow the part to solve, and right away SolidWorks Simulation Express will give you a quick snip animation on how the reaction of how the part will react to forces that you have applied, based on the forces you've applied. Now, based on how this part is reacting, you can see it actually has that hand wheel motion, that it's being cranked based on that force being applied in that vertical direction. So to answer the question here, does the part deform as you expect? I'm going to say yes, continue. And the next step, step 5, is where I can view all the different results that SolidWorks Simulation Express provides to me. So here the first result is the von Mises stress. So within the von Mises stress itself, I can see where my yield strength is placed and some of the areas which is surpassing that yield strength, and kind of in the red zone, in the danger area. So you can see that that end of those spokes there, it's not very good, so this might not be a very good design. So if I show my displacement instead, the highest displacement that occurs within this part is 1.19 millimeters, so it might not be that bad after all. Based on my factor of safety, it is found to be 0.586, so it is half of the force that I applied, 3000, so it should be able to withstand up to 1500 without any problems. Alright, so at this point you can say done viewing results, and the next step is you can actually produce a nice Word document or a report for you to keep in your, to print out and keep on your desk, or to file, or even to give to a prospect or your customer on some information that you got running this simulation. So in this case I can say generate report, and I'm going to say in this conclusion that this part may fail due to very high loads above 1,500 newtons. Alright, and I'm going to say generate, and you can see as long as you have Microsoft Office 2007 and above, it will automatically tie into that software and generate this report for you. Right away I get that report. You can see that this is the 10-page report, very good, quite a bit of information, and you can see that it has the part itself. It shows the type of properties the part is carrying, such as the mass, the volume, the density, the weight, based on the material that is being set, which is brass. You can see how the part is being fixed here, how the load is being applied onto this part, the mesh information that went into creating this part, how the mesh actually looks, and last but not least the result, which is probably the most important part of this report, and your conclusion, which I essentially wrote in. Okay, this document is fully editable. You can edit it, save it, print it out, and pretty much do whatever you want with it. Okay. Alright, so you can also generate eDrawing files. So what this does is it allows you to send all that results into your eDrawing, so you can send it off to someone and they can even view all those results within the 3D models itself with all the pictures and all the colors. Give them a good perspective rather than just looking at a report or a PDF document. So here I'm going to hit next. Now in this case, if you're not happy with your results, you can actually optimize your model. So let's take a look at optimizing this design here. So would you like to optimize your model? I'm going to say next. And what would happen is that the part would bring up all the dimensions that went in to build that part. And you can actually start picking dimensions to create parameters, and using that parameter you can build different range or different sets of dimensions and run an optimization study. So in this case, the spoke that it showed me that the spoke itself might not be thick enough. So in this case, that spoke dimension here is actually 14. So I might want to bump that number up to perhaps 18 or 20 or 22. Now I'm not sure if 18 is going to be a good enough number, or perhaps 22 might be an overkill. It really depends on what I'm trying to do for this part. So what I'll do is I'll pick that 14 as my parameter, and here I'm going to say okay to add that to my parameter list. And instead of using a range, I'm going to use well, I'm going to keep it using a range, but I'm going to set this number between 18 to 22. So 18, 19, 20, 21, and 22. It will run 5 different instances, and based on some constraint that I'm setting, it can optimize and actually tell me which would be the best dimension to set this up to. So here I can say maybe factor of safety is greater than 1, just so that I can hit that 3000 newtons mark, and my goal is to minimize my mass. So that's fine. I can set that, leave that as is. So as soon as you've set up your 3 conditions here, just hit run. That's it. There we go. Right away, the Simulation Express will run 5 different instances, and it will give me that optimal number for my 5 different instances. So here what it says, optimal is 22 millimeters, so it's going to be that maximum number, which and only in that 22 millimeters I will get that one number above 1 for my factor of safety, and the final mass would be 3.34 kilograms, which is something that I could probably live with, not much difference from my original mass. Pretty nice, concise tool to use. Again, readily available. You can start using that as of today. Alright, so that's all I wanted to show for Simulation Express today. Now let's head back into our PowerPoint. Now, as I had mentioned before, this Simulation Express by no means should be used to replace a full-blown FEA analysis within your design cycle. So to be able to run your virtual prototype testing, SolidWorks has a SolidWorks simulation suite. Alright, next up, let's talk about FlowExpress. Now, FlowExpress is a CFD package, CFD version of the Simulation Express. So many of you know that SolidWorks has a full-blown CFD package which is called SolidWorks Simulation Flow, And this is essentially that first pass version, which allows you to calculate how the fluid will flow through your part or assembly model, and allow you to find any pressure areas within your enclosed parts, and it will also show you how the fluid is flowing. So if there's any leakage in your model, or if there's any pockets where fluid is building up, it will show you based on the velocity field within your FlowExpress itself. So let's take a look at an example of this within SolidWorks. So I'm going to just close this out. So what I have here is a globe valve which has a fluid flowing through this and fluid flowing out of this. Now, unlike SolidWorks Simulation Express, which you could only run on SolidWorks parts, SolidWorks Flow Express you can run on parts and assemblies. Now let's take a look at a section view of this valve, and you can see how the inside is built, and essentially how the fluid will flow is in here in the input, and then the outlet right here, the inlet and the outlet right here. Now, the one most important step when creating a FlowExpress is that the part needs to be airtight. So in this case, you can actually see I have two lids here which completely closes up that inside volume. Now, if I were to simply suppress these parts and start to use my FlowExpress tool, now when I start the FlowExpress, it will say welcome to the SolidWorks FlowExpress, very much like the Simulation Express, and I hit next. If I say view fluid volume, if I hit OK, now that is not correct, because the fluid that's running through the system should be within the inlet and the outlet. So essentially now you have a model which has a leak in it, and this will not run correctly. So you have to fix that within your model itself. So one way you can do that is you can just simply come in here and create a lid by sketching on that face. So here I can just come in, use a sketch on that face, use convert entities, select that circle, say OK, features, extrude. Make sure you uncheck that merge result because it has to be its own body. The extrusion should be towards the inside of the model, so I'm going to change that direction, and I say OK, and that is my lid that has been created for this part. Okay, so let me go ahead and unsuppress the second lid that I have here. I'll turn off this lid as well, just so that I can keep the consistency of the thickness on both sides. Alright, so now I'm ready to run my FlowExpress. You can see right here, if I say view fluid volume, that is the correct volume within my part itself. Now this functionality alone is very useful when it comes to designing airtight products, or products that have, or assemblies that have fluid or air running through it, because you can see how the distribution of that fluid or air within your part is. Now once I have verified that it's an airtight part or without any leakages, I'm going to hit next. And you can pick to either have water or air running through your system. So in this case, I'm going to just say water. Hit next. Now the first step is to apply the type of flow for your inlet. So for my inlet, I can either pick just a pressure, I can say volume flow rate or mass flow rate. So in this case, I'm going to say volume flow rate at 1 inch cube per second, and the temperature that I'm going to pick is about 68 Fahrenheit. I'm going to hit next. Now for the outlet, it's simply going to be atmospheric pressure. So as the fluid comes and hits this outlet right here, it's basically flowing out into the air. I'm going to hit next. That's it. I solved the simulation. And right away it will show me the water molecules or water particles within my system itself. Now to give you a better preview of how this fluid is going to be running through your system, you might want to pick the pipes and just hit play, and you can actually see that trajectory as it's flowing through your system. Now what's nice about this is you can see how that fluid is kind of building up down here, so you might want to change the dimension of that curve down there, and you can also see how the velocity is at that valve opening right there, and also as it comes out the valve, is it picking up the velocity or is it losing velocity as it's coming out. These are the type of information you can get from your FlowExpress. So in this case, we have a pretty successful part where the fluid is running through the system without any problems. Now again, just like Simulation Express, you'll be able to generate a report for FlowExpress. Just hit generate report, and you can see that I have a Word document which gives me all the information with the inlet, the environment, pressure at the outlet, and the velocity running through my system, or what the velocity is at. Alright, so that wraps up SolidWorks FlowExpress. Now just like SolidWorks simulation, FlowExpress is by no means a tool to replace any kind of computational fluid dynamics analysis that you may or may not be running in your current facility. So if you do need to run any type of fluid flow analysis, SolidWorks Flow Simulation can address those types of analysis. So you can see here that we have an array of analysis types within our SolidWorks Flow Simulation. Okay, so next up we have DriveWorks Express. And DriveWorks Express is essentially a rule-based design automation software that allows you to automate a design process. So for example, if you look at this picture that we have here, this is 4 combinations of a scissor lift assembly. Now the parts that are being used are essentially the same. What differs is perhaps either the size of the parts or the number of parts that go into the assembly. Now using an automated process, DriveWorks allows you to create multiple assemblies such as this automatically. So I'm going to start this portion of the presentation by opening up an existing assembly that already has DriveWorks set up in it. And the reason I'm doing this is because I want to show you the amount of capability and the depth of capabilities that's already available within DriveWorks Express, and this is pretty remarkable considering that this add-in is already available within your version of SolidWorks right now, and it's again completely free. You don't have to pay anything extra to get access to this. So what I have here is a shelving unit which has every bit of part included in it, and it basically includes all the cam locks, it includes all the pegs that hold up these shelves, all the cutouts for the pegs. It even includes all the screws in the back to hold the backboard, and all the material have also been set in this assembly. Now when we invoke DriveWorks Express, the first thing to make sure that you're in the right database. So I'm going to create or actually set a new database. Which is this .mdb file, and this .mdb file gets created when you start up a new DriveWorks project. So this is a completed project again, and you can see from my menu here, I can pick and choose some different combination of this assembly to create a completely new assembly. So let's go ahead and play with some of these numbers. I'm going to say the height of this is 600 millimeters. I'm going to keep the depth the same. I'm going to keep the width the same. I'm going to add number of shelves. I'm going to say 5. And I'm going to change the material to pine. And watch what happens when I say create. You can see all the parts that go into building this shelving assembly is being recreated in the background, all automated. And even all the drawings that are associated with the assembly also gets created for you automatically. So you see here I have, you can actually see all the process that it went through to build this new assembly, and voila, a whole new assembly with the 600 millimeter height and 5 shelves as I picked in my menu. Also a new material. Now if we take a look at our folder that we created, you can see here all the new files were created for me, and even more so, you can see that I even have a drawing that has been updated automatically for me. Now keep in mind there was other equipment included in your assembly, such as the cam lock and the peg. They all updated to its correct new location, and all this is done according to how you had set up this assembly, how you have created this assembly. As long as you have put all the right information in, you'd be able to create multiple assemblies such as this. So now let's take a look and let's kind of go in the background and just kind of see how we can create something like a shelf, something like this. So I'm going to open up a model that I have here. So this is a simplified model. I took all the cam locks and the pegs away. And what I'm going to try here to do is I'm going to set up a new DriveWorks database project which only drives the height of my shelving unit. So if I change basically it gives me 3 options. If you want a 4-unit shelf, a 6-unit shelf, or an 8-unit shelf. So depending on what I pick, the new assembly should automatically creates it. So let's start by creating a new database. So I'm going to say create database. I'm going to say okay, and I'm going to say this is for our demo. I'm going to say open, and I'm going to say add a model. I'm going to say use current open model. And when you select this assembly or any assembly, the first thing that you need to do is you need to say capture assembly structure. Now as soon as you say capture assembly structure, everything that goes into that assembly, all the parts are listed in this menu here. Now this part of the DriveWorks is where you pick and choose the parts which would essentially change when you pick different assembly types. So here what would change is the shelf left end. This would change because the height would change, the shelf back would change, and the shelf right end would also change. So those are the only three that essentially would change if I were to make a different height of this assembly. I'm not changing the width or anything in this case. So pick those three, and I hit what I can do now is I can say dimension and features to drive these changes. I need to apply some sort of condition or create some sort of condition for those dimensions and features to drive the model. So I'm going to pick I'm going to double click the part itself, and you can see that I'm going to pin this in just so that it stays there. And if I pick on dimensions and features, if I pick that dimension, I can say left height and add that in. Shelf back, back height, and add that in. Hit capture model, and then the right side, double click that, and right height, and add that in. Alright, now that I've added those three dimensions to drive my height, one more thing that will be affected in my assembly when the height changes is the number of shelves, because that's basically driving the type of form that I'm going to create. So it will be a good idea to create a dimension driving dimension for the number of shelves that is going to be created. Now the number of shelves that are being created in this assembly is being driven by a shelf pattern here. So I'm just going to click on that, and you can see that the number of shelf is brought up right here. So I'm going to click on that, so that shows up as a dimension, and I'm going to say number of shelves and add that in. Okay, so all this is set. I'm going to say next. Now what is going to be driving the change of this assembly? So this is going to be number of shelves, and I'm going to have this as a drop down menu, and I'm going to have 4, 6, and 8 is three different types of shelving unit that I can have. Is a 4 unit, 6 unit, and 8 unit. And I will say next here, and in this page is where you set up the conditions to change that form that you've just created. So in this case, I'm going to say create a rule. So you can say I have 8 rules here, 4 missing for names and 4 for dimensions. So let's pick both these and say next. Now for the file name, what they're basically looking for is when I change when I create a new assembly, what is driving that new name. As you saw in the earlier example, when I created the 5 unit, it created an assembly with a .5 at the end, because that is the number of shelves. So I'm going to use the same technique here. I'm going to say build, I'm going to say equals, and you can input number of shelves. So you can see what it actually gives you some information here. File name rule specify text to be appeared to the original file name. So when I create another assembly, it's going to say shelf 6.asm SLD ASM. So okay here. So all that rule has been satisfied. Now I have a number of shelves here. This is being driven from that pattern. So I'm going to say build here. Now keep in mind 3 pattern builds 4 shelves. So what does this mean to me? When I say 4 shelves, it's 3. When I build 6 shelves, it's 5. When I build 8 shelves, the pattern is 7 because there's 7 actual shelves on the inside. So this actually means when I say number of shelves, it's going to actually equal the number of shelves that I input minus 1. That will actually give me this number, right? So if I say 4 minus 1, that's 3. That's the base unit that I'm starting with. So I'll say okay here, and then I have these 3 which is right now set to 400 millimeters, so it needs to change according to the distance of these shelves, 4 unit, 6 unit, 8 unit. So I've built a small equation that will help me do that. You can see that I have it right here. And what this essentially does is, this is 18 is the height of each shelf, and 78 is the distance between the shelves, and that will create the new height for me when I change the number of shelves. I'll say okay here. So now I have all my rules have been satisfied. So essentially that's it. I should be able to drive this assembly and create new assembly with that new form that I've created. So let's go ahead and say run. And let's specify the number of shelves here that I need. So let's say I'm going to create a 6 unit shelf, and I'm going to say create. And there we go. It's a 6 unit shelf. Now let's make one more. Let's create an 8 unit shelf. And I say create. And it creates the 8 unit shelf for me. Very easy to do. Alright, so that kind of concludes the DriveWorks portion of this presentation. Again, there's quite a bit that can be done in DriveWorks. Everything that you saw today can already be done in DriveWorks Express. It's fully available to everyone that's using SolidWorks right now. Now, if you would like to have more control over the type of automation that you're doing, where you can even include a sales quotes, a BOM, then you can step into the DriveWorks Solo, and then if you want to try to integrate your PDM systems or your ERP systems, you can then upgrade to the DriveWorks Pro. So to get more information on the type of tools that are available with DriveWorks, and tutorials and free videos and how-to video clips, please log on to driveworks.com. It's a great website, a lot of tutorials there, and again, DriveWorks Express, great tool, readily available. You can start using it as of today. All right. So last but not least, DFM Express. So DFM Express is a very nice tool that allows you to validate manufacturability of your parts. What this allows you to do is identify areas in your assembly that may cause problems during manufacturing or fabrication. So any part that goes into milling or drilling or turning, even sheet metal and injection molding parts can be tested using DFM Express. So DFM essentially stands for Design for Manufacturability. So this tool is a simplified tool to test your parts in those environments, in that manufacturing environment. So let's go ahead and take a look at an example of doing this within SolidWorks itself. I'm going to open up a part here. So here I have a part. It's like it's probably from a plastic mold part. However, you can see there's a lot of holes and cutouts here within this part, and I want to ensure that this part will be able to manufacture well without any fabrication problems. So if I go into my tools, Express Products, and select on DFM Express, now as soon as you open up the DFM Express tool, the first thing you want to select is your settings, because this is where you can set if the manufacturing process is a milling or drilling process, it's a turning process, it's a sheet metal or injection molded part. So clearly this part that we have here is just a mill and drill part. Now DFM Express would test your part based on a set of parameters that has to come from your engineer, your designer, and basically it is the requirements that you set for your parts. Now some of this information can actually come from your machining handbook or even from your machine manual. So in this case, some of the parameters that I can set here is, for instance, hole depth to diameter ratio, hole percent of hole area, minimum percent of hole area inside part, mill tool depth to diameter ratio, minimum linear tolerance zone, minimum angular tolerance zone. You can also edit the standard hole sizes to set up some custom hole sizes that you may have in your facility. So I'm going to leave this at the default values and hit run. And you can see right off the back, the milling and drilling process has 10 requirements, and I've only passed 8 of them. Now if I drop the rules that I've passed, you can actually hover over the different rules and you can see what are the requirements to pass them. So one example is deep pocket and slot. Now many of you know if you have a deep or narrow slot, it's very difficult to drill that. Now that's something that you can build into your 3D part without knowing that it might be a problem when you go into the manufacturing stage. So this ensures me that there is no such feature in my part. However, I did have 2 failures here. Now the first failure is the hole depth / diameter ratio failure, and this is actually based off the requirement that I had set earlier. Now if I drop this down, you can see that I have 51 instances of this failing. So basically there's perhaps 51 holes where this is failing. So if I pick on that first instant, it actually shows me where it fails. If I pick the second instance, it shows me where that hole is. So this is a very helpful tool because not only it highlights the hole within the part, it also highlights the feature in your feature manager. Now going back to instance 1, you can see that, well, maybe I made a mistake in the settings, so I'm going to go back into the settings and I'm just going to bump this number up to 9 instead and rerun this analysis. Now having bumped that number up to 9, you can see that I've passed 9 rules and I only have 1 failure at this point. So when I hover over that failure, it says fill it on outside edges, and the explanation says that outside corners, chamfers, requires form relief cutter and a precise setup, both of which are expensive. Now if this is something that you have to have in your part, you can just disregard that and continue on with your manufacturing or your part design. However, if this is something that you might want to avoid high expensive parts, then you could fix that before moving forward. So in this case, again, I can just pick on that on the instance right there. It shows me where that outside fillet is located. Again, it highlights the feature right there for me, so I can right click that feature and say suppress, takes it right away, and you can see that that instance 2, it's actually gone right now, is because that was the mirror of that fillet on the other side. Now sure enough, if I run this again, you could probably already guess that I would get a 10 out of 10 passing rule. So the DFM Express doesn't stop there. There are many other manufacturing processes that you can play with. So for instance, you can also take a look at a sheet metal part. Now when we have a sheet metal part, I can set sheet metal, and you have some different types of configurations here, or parameters here, that you can set up. So again, I'm just going to leave this at default and say run. And you can see that I've had one failure, and the failure that I have is the bend radius may not be enough in this case. So here's when you can go back into that sheet metal tab on the top here and change some of your bend radiuses. Alright, so I hope this presentation today has given you a good idea of what SolidWorks Express Tools is capable of. Again, all these tools are available. Go ahead, start playing around with it today. If you have any questions at all about any of these tools or SolidWorks itself, please feel free to shoot me an email at sashi@caddimensions.com. If you feel free to give us a call as well at 877-223-4255. And please do visit our website at www.caddimensions.com, where you'll be able to find more videos such as this webinar that we have recorded today, and also tips and tricks from previous webinars and presentations. So again, thank you for joining me today. Hope you all have a great rest of your day.